지금 나오나요? 유튜브. 야, I think screen이 아직 okay. Okay, good morning in the Netherlands and 안녕하세요. My name is Juwon Lee. I work for the Netherlands Embassy in Korea. I'm glad to host the Korea and the Netherlands hydrogen webinar today. And for Korean viewers, from now, most of the contents will be in English, so I'll speak in Korean for a second. 지금 저희 네덜란드 수소 세미나를 시청하고 계신 한국 시청자 여러분께 알려드립니다. 본 행사는 모든 발표가 영어로 진행될 예정이고 발표 중에는 이제 통역을 지원하지 않으니 양해를 부탁드리겠습니다. 만약에 웨비나 중에 질문이 있으신 분들은 유튜브 채팅란이나 줌 채팅란에 이제 글을 남겨주시면은 제가 그거를 통역을 해서 이제 전달을 하도록 하겠습니다. 그리고 이제 B2B 매칭을 원하시는 분들은 이제 유튜브 채널에 있는 B2 매치 사이트 링크로 가셔서 기업 정보를 입력하시고 해당 사이트를 통해서 미팅을 시청하시면 되고요. 현재 80여 건의 미팅이 이제 요청을 되고 있다니 이렇게 로그인을 해서 확인해 주시면 될 것 같습니다. 그리고 다음 주 수요일부터 금요일 사이에 코엑스 홀 A의 H2 월드가 인터배터리 행사와 함께 있을 예정인데요. 저희 네덜란드도 이제 대사관 부스로 참여를 할 예정입니다. 이때 부스를 방문해 주시면 또 많은 정보를 얻으실 수 있을 것 같습니다. So back to English now. I'd like to orient you the first about this event. So could you show the today's agenda now? The hydrogen is a hot topic in both Korea and the Netherlands. And the Netherlands is a country with a natural gas well and chemical plant hub in Europe. So hydrogen is a familiar gas and it has been utilized for years. But now it became the alternative source for fossil fuel and energy storage media. We are planning to have a Dutch hydrogen delegation this year, but due to COVID-19, we decided to have this digital mission instead. But I'm still excited to see how this new digital interface will work out for the next 2 weeks. We have over 30 Dutch participants from research institute to large manufacturer and also the private consultancy. I expect more Korean viewers are also watching this from Zoom and YouTube channel. The goal is to network and get to know each other, and hydrogen is at the beginning phase now, so which obviously need a joint effort and competition. As you see, there are 2 weeks of the program. You can see the screen backside. Cannot see now, but actually this is the 2 weeks of program. The webinar is for today and Wednesday and Friday this week. And other module will be the business matchmaking between Korea and Dutch companies through this B2 Match site. The link is on the YouTube website. And the third module of the program is the exhibition at COEX next week. So the embassy will present Dutch hydrogen business at H2 World Exhibition from Wednesday to Friday next week. And today, the webinar will focus on R&D and safety evaluation with Dutch and Korean presenters. I'm honored to have Dr. Taehyun Yang, who is leading the hydrogen research at Korea Institute of Energy Research, KIER, as the invited speaker with us today. He will share the development in Korea after the Dutch speakers present. For online presenters today, please present. We'll present the files from our side, so you can just say the next slide, or please go to the next slide. Then we will do the operation here. Each one have 10 minutes to pitch, and question and discussion will be allowed after we finish all the presentations. So I think we will start from NRR, the Netherlands Aerospace Research Center, Mr. Fout Gadoor. The online stage is yours.
Thank you. Good morning to you all. Goedemorgen allemaal. Annyeonghaseyo. So as I'm waiting for the slides to appear, I'm Fouad Gadour from the Royal Netherlands Aerospace Center. And I will explain about what NLR does specifically by putting the domain of aerospace and hydrogen together. Next slide, please. So I'll go briefly through, let's say, who NLR exactly is. We have 100 years plus experience in aerospace. And we are active worldwide with a very broad knowledge in topics in aerospace. Next slide, please. So I already mentioned very broad knowledge. So in all fields of aerospace, from systems to operations to the vehicle development itself. Next slide, please. So if you look at hydrogen, this is a breakdown of all of the kind of activities we have within NLR. So you can imagine if you look at hydrogen, flight testing and certification becomes quite important, but also safety is a major aspect, but also looking at policies and of course propulsion. So we have a lot of cross-fertilization going on between the different divisions. So we can optimally support our clients. Next, please. So how are we positioned at NLR? We are an R&D institute, non-profit. We are mostly in TRL 4 to 6. So in the dead center, we help the university bridge that gap from fundamental science into applied. And we will basically help support industry in translating their innovation ideas, and production and commercialization is done by the industry themselves. Next slide, please. This shows you just what we have achieved in that 100 years. Next slide, please. So let's dive into, let's say, NLR's research into electrical, hydrogen, sustainable means of propulsion. So what do we do exactly? We do all kinds of calculations, so aircraft level analysis. We look into the propulsion itself, but also setting up the infrastructure for that, the operation side, mostly related to safety and regulation. What kind of impact the different solutions have, certification, what is quite important in aerospace, but also other domains, and of course the powertrain research. So if you look at it, it's very important to look at how can you enhance the endurance of hydrogen, because this is the most important, you know, having that range in aerospace, but also looking at safety aspects and certification standards themselves. So what you see here, we have the hydrogen drone, where we have done several flight tests already, which was the first in the Netherlands. We have all kinds of new projects like scaled aircrafts, where you can have the same results as the big aircrafts, but de-risking by using a scaled version. So you can do all kinds of tests with all kinds of new systems, but also new propulsion types like hydrogen. And recently we also have acquired the Pipistrel, which is an electrical plane, where we can also do a lot of tests, flight tests related to hydrogen as well. Next slide, please. Yes. So we also have a testing lab dedicated to hydrogen. We call it the Data Lab, testing of hydrogen electrical technologies for aviation. And already mentioned the importance of power management and increasing that endurance. What we do there is basically the hydrogen powertrain research. So we look at how can you put in that improvements related to different components. We can do all kinds of testing in the laboratory. An example of that is testing of a hydrogen fuel tank, looking at standards, but also NDI. And then the idea is of let's say the capabilities, the expertise, the testing facilities is to stepwise increase the power and endurance. And if you look at the right side, you will see the roadmap that we envision. So starting now with 2 kilowatt and ending up 1 megawatt. And the idea is to stepwise increase this. And later on, I will show you the time plan that we have in mind. Next slide, please. So I talked about the test that we did with a hydrogen drone. This was a first in the Netherlands, where we have flown a quadcopter with a 2-liter hydrogen tank in gas form. And we already put in some customizations with extending the endurance of that flight, that first flight. And with this, we can build up our knowledge and expertise in testing this kind of systems by looking at all kinds of aspects, like the hardware itself, ground testing, and of course, safety, which is a very important aspect of this testing, coming up with contingencies, looking at the standards out there, and handling and cooling. Next slide, please. So you can watch a video of this first flight on YouTube. I've left a link to do so. Next, please. But we can skip this one, yes. So how does it look like, the Hydra construction of this quadcopter? Of course, we have the hydrogen tank mounted above. And then the fuel cell, which translates, of course, the hydrogen into the energy, and all of the pressure lines there. This gives you an indication on how this whole system is set up. Next slide, please. So already explained about the importance of safety and risk assessment. That's why also we did the flight test to look at the different aspects, and what is very important in doing this kind of test is to have an adequate flight test plan, and doing that safety analysis needed, but also with a strong focus on prevention of human casualties. So we have a kind of a risk matrix that we have put into place that can be used also for a future test, because as technology advances, sometimes regulations lag behind. So currently in the hydrogen field in aerospace, there are no clear cut of standards of regulations out there yet. So you have to develop a lot of things for yourself. So that's why we came up with a plan that takes safety into the highest regard, with focusing on different aspects. So if we go to the next slide. This gives you also an overview of the safety measures that can be put into place, like looking at leak testing, but also anti-static measures, of course, looking at explosion danger as well. Next slide, please. And what I want to highlight here is in the NLR, we have our own testing center, Netherlands Airpass Testing Center, with our own airspace. So if you look at legal requirements, we have our own permits and exemptions, so we can fly all kinds of prototypes in this airspace. That makes it quite easy to do this kind of experimentations. And also, it's not only the site, or it's not only the aspect of flying, but also operating the drone itself. You have to have permit for that as well, and that we are also approved as a center to operate these drones. And what you saw in the earlier slides, we did a test with a quadcopter, and we already now doing also test with fixed wing, which is a much heavier platform, and we want to go towards, of course, more and more payload in the future. Next slide, please. So this gives you an idea of how the fuel cell is modeled. So I already explained it's not all about the operating, the certification. We also want to enhance the power, the endurance. So at NLR, we also look at power management, energy management. How can you optimally fly a quadcopter? And that's why we do all kinds of have all kinds of algorithms and do all kinds of simulation and modeling. Next, please. These are just some specs regarding the first test flight we did with the Hydra 1. Hydra 1 is the quadcopter and Hydra 2 is the fixed wing. So you see the drone weight is 8.3 kilograms, and we have a demonstrated endurance of 38 minutes, which is quite significant. And this payload, let's say endurance can be enhanced by, of course, looking at mass savings. So for instance, you can have small things like having a composite fuel tank, what can save in mass, what can also extend the range, but you can also look at extending the output itself as well. Next, please. So you see here some some specification for the Hydra 2, what we want to do. So we want to go up to the 95 minutes and more with small payload weight. And next, please. So what do we want to reach? This is kind of a roadmap we have within hydrogen research. So short term, we already have accomplished a lot. We're doing that Hydra 1 flight test. And what we want to do is with the Hydra 2, extend that with a fixed wing VTOL drone and have a much longer endurance, so 2 to 5 hours, which is quite significant if you look at the drones that are out there now. And the problem we have now is there's, of course, a lot of focus on an electrical flight, but the technology is not out there yet. And the results that have been shown by hydrogen are much more promising, also looking at the endurance-wise. So if you look at future concepts like urban air mobility, where most of the platforms will be electrical, hydrogen could be a very interesting substitute for that. So that's why research in this area is quite important. That's why we want to accelerate as fast as possible. So midterm, 1 to 2 years, we have a flight demonstration in mind for cryogenic. So we are going more toward liquid. Now we are focusing on gas. And also looking at the range extenders, like already mentioned, the Pipistrel, which is an electrical aircraft. Long term, 3 to 5 years, where you've seen, we want to have that flight demonstration of hydrogen-powered UAM, because we see that that is a trend that is coming in the future, probably around 2030, where there'll be a lot of urban air mobility platforms flying around, which needs to be sustainable, with the great push from the European Union, also with the Green Deal and sustainable aviation agreements. This comes more and more important. So what can NLR support? We can support with flight testing campaigns, operations, certification standards, because if you want to go into aerospace with hydrogen, it's a high-tech, high-spec, high-standard environment, so we can help with that. We can also look at enhancing endurance. So we can really partner up with industry, government, or university R&D institute from Korea. Next slide. So just as an example of what we already do in Korea, we have a project with KCTech, which is specializing in carbon technology. This is a good example of how we can collaborate in Korea, is where KCTech has an extensive experience in hydrogen fuel tanks for the automotive application. And we have, of course, that experience in aerospace. So we're combining these two worlds together to come up with a nice solution to the challenge at hand. And this project, we look at standards, for composites, but also non-destructive testing, which is needed to demonstrate that they can reach certain standards. So this is the support that we give at this moment to KC Tech. So I think this is my last slide. Next slide. Oh yeah, this is the last slide. So kamsahamnida. Thank you. Dank u.
Yeah. Okay, thank you, Wout. So next speaker will be Mr. Heiko van der Heyden from TNO, the Netherlands Applied Science Research Center. Heiko?
Yep, okay. Yeah, Shimika, Haikuimida. Yeah, okay. Yeah, every country actually has its own way of dealing with hydrogen. And if, what you see actually on screen is the interpretation of Hyundai at the Hyundai Motor Studio in Goyang, which I took last week, on how that actually behaved and how it's presented to the public. So that's a very interesting way to see it, and I think we come to more to how you present it to the other companies, public, how hydrogen will be accepted in the future. Next slide. Yeah. Now, TNO was established in 1932 as a research institute for the military. We have around 3,500 people, 45 labs, so we do a lot of testing. And most of these tests are not dedicated to one topic. It depends on the circumstances around the test, and then that determines what kind of lab we're going to use. We have bunkers for the safety tests. We have mechanical test labs. We have robotics test labs. So it depends on the situation, how we're going to use the lab. So for the hydrogen, we can use actually all labs if we need them. Next slide. Okay. TNO works very multidisciplinary, and you can see that in all of the projects. So that's why I put this one on. So we now have specialists on energy storage, CO2 infrastructure, how to use polymers, how to use fuels, renewable energy, wind. So all of these different specialists, they can work together in one project, and that makes TNO thoroughly flexible in handling all kinds of challenges in introducing new technology into society. Next slide. Okay. And the biggest battle we have at this moment is actually the COVID-19. And this is very similar to the introduction of nitrogen. We have to work together across the world to get hydrogen introduced as a new fuel. Also with COVID, there's enough data, and also on hydrogen there is enough data, but still some of the steps are really essential which we have to take. And that it actually makes a difference in introducing hydrogen as a new fuel. Next slide. Okay, as we can see from this calculation from the International Energy Association, hydrogen definitely has the future, but not all of it is renewable. There's still a lot of hydrogen being created from fossil fuels. Also, the use of hydrogen across the industry is it's also very promising. We see a lot of usage actually increasing, and that also determines that still a lot of work has to be done in getting hydrogen introduced, not only as a fuel, but also across other parts of the industry. Next slide. Okay, but all these models and all these predictions, they vary very, very widely. it really depends on the assumptions you take, what actually the outcome is. So although the prediction that hydrogen will be a very good alternative fuel for the future, that is definitely true. How effective that's going to be, and if it's going to be effective in all cases, that's still a big question. And that's why within TNO, we can do these kind of studies. We have done them in the past as well. We're still doing them, but you have to adapt them really to the local situation in order to be of any value. So next slide. So instead, we look really at, okay, what kind of research topics we have to tackle to make hydrogen actually a suitable fuel. Next slide. Now, for that, it's important to look at the whole spectrum from generation of the fuel, conversion, storage, distribution, and usage. And all of that has advantages, disadvantages, safety aspects, costs involved, and that really, if you look at the full spectrum, that determines whether or not hydrogen is going to be a good alternative. Next slide. Now, as such an example, in Netherlands, we do have a lot of wind energy already. The cost of wind energy is actually dropping quite considerably already. You can see that in the black graph. And the price of the electrolyzers is also dropping. However, the usage of electricity is also increasing. So that means that for now, and probably until 2030, there will not be that much electricity left to produce hydrogen. So the people are working very hard at installing more offshore wind turbines, but it is a challenge to get enough energy for, or let's say, enough green energy available for hydrogen production. At TNO, we already have a wind turbine with a electrolyzer on a test site. Okay. Next one actually is the carbon capture. We have to be realistic. CO2 is a problem, and for this time being, it will be captured. So it's very important. Like, can we do it efficiently, and can we do it? And what can we do it with the CO2 afterwards? In the Netherlands, we use a lot of CO2 in greenhouses. We have dedicated pipelines for that. That is, of course, not suitable in Korea, but it shows how you can use different technologies in dealing with the problem. Next slide. Now, one of these things, for instance, we looked at TNO, is how we can use CO2 to make different products. There are a lot of opportunities. Now, in the two graphs, one is about using adding hydrogen to CO2. Then certain, like formic acid, looks very, very promising that can be made at reasonable cost, and the selling cost is also quite high. Another option is to use electrons. Also there we see that there are a few products which look promising. One of them is acrylic esters, which is used in the plastics industry. But you also see that a lot of usage of CO2, if you want to use it for a different product, is not feasible because too much energy and too much costs are going into it to make that possible. These numbers are made for the Netherlands, and of course in Korea that is different, but we can do a similar analysis. Next slide. Now, within the TNO, we also do a lot of powertrain testing. We always look, most of the powertrains for ships, buses, trucks, they will be hybrid, so there will be a fuel cell or a hydrogen combustion engine combined with a battery pack. And all of that has to be optimized, looking at how this particular transport system is actually used, and that determines actually which one is really most suitable for it. Next slide. Okay, one of the biggest challenges for hydrogen is actually storage, and that means that we have to look at different storage opportunities. In this particular case, we look at the ship, and we want to actually use the hollow areas in a ship to store for storage tanks. However, due to a design rule from the 1930s, this is officially not allowed. But if we want to move to hydrogen for shipping, this is an option we have to make. We have to consider. It can be done. We have done it already for LNG. It can be done safe, but it does require challenging the rules and regulations around us. Okay, next slide. Okay, it also means that a lot of components need testing. Sometimes very extreme tests, low temperature, extreme high pressures. That also requires special laboratories where these tests have to be done. Fortunately, within TNO, we have these available, but we always want to work with companies in Korea or abroad, in other areas where we can test components, materials, and under extreme conditions. Okay, next slide. Now, this is an example of a LNG test site we actually are currently developing in Korea. That's also the reason why I'm currently not in Seoul with the people from the embassy, but in Changwon with my customer, because this is what we are developing here right now. And that's actually to develop the transfer system itself and the simulation, and to test all the safety features of such a system, and to mimic actually, okay, what does everything work correctly, and help the Korean companies to develop their own transfer system, and also for the European manufacturers to test their systems as well. This should be operational towards the end of beginning of 2021. So next year we're going to build this. We already started with design, but yeah. Next one. Another important aspect is actually safety. Like for how long? Okay, so for how long is it, for instance, safe? We look at the circles to determine the safety areas around it. So that is all something which still has to be considered. Okay, next slide. I think that's the last one. Yeah. So this is an overview of where we think at TNO the next developments will have to do. Electrolyzers, large-scale hydrogen generation, safety of transport and regulations, and also people and training. So for this, actually, in Korea, we're looking for partners who want to undertake the development in those areas. Okay, this is Heiko van der Heijden representing TNO. Thank you very much for your attention.
Okay, thank you, Heiko. The next. Okay, thank you, Heiko. Thank you. And next speaker, Mr. Danton Hopper from KIWA.
Yes, good morning, everybody. This is Daan ten Haaf speaking. I'm working for KIWA in Apeldoorn. That's in the Netherlands. I'll try to keep it a little bit short. It's not that we have a very short company, so to speak, but I'll give you an indication and then a little tour through our company as for today. Next slide, please. We are a worldwide based company. We have at the moment approximately around 4,500 people working at our company. Originally, we were based in the Netherlands as a water company, where we are doing in the early stage of just after the war or early after the war, some water development projects, and as the time went on, we got a big expansion going on, and our expertise at this moment in Apeldoorn is mainly involved in gaseous energy carriers. As you can see, we have several companies in countries throughout the world. Korea is one of them. We have an office in Seoul, where our colleagues are working mainly in gas appliances. Our markets are quite diverse. This presentation is mainly focused on hydrogen, but as KIWA is involved in so many different markets, yeah, we call it a one-stop shop, meaning that well, there is not much questions unanswered within our company for several customers. Our core activity is TIC, it's testing, inspection, and certification. Next slide. When we're talking about hydrogen, in this case, as an energy carrier, on the left of the screen, you can see, we call it the hydrogen wheel. It's focusing on all the services KIWA can offer. The outer ring, for example, you can turn, you can rotate it, so you can see that, for example, a feasibility study, a research, consultancy, development, support, or an international network can be changed throughout the hydrogen systems, which are applicable in, let's say, development country where hydrogen will take a big role in the future. Meaning that, for example, a feasibility study can be done in various range of markets. Automotive could be a feasibility study. There could be a feasibility study in storage. But on the other hand, we can also do development or consultancy in these areas. So you can, we try to visualize the diverse expertise we have within our company, meaning that well, there are so many options we can offer. Next slide, please. In this case, we try to visualize as well the hydrogen landscape as we see it. So if you take your left-hand side, you can see what Tino also mentioned, how is the renewable energy created? So you have wind, you have solar, several other options. How is it managed? How is it stored? How do you integrate into a grid? How does it integrate it into in a production facility, like an industrial hydrogen production facility? As you can see, KIWA is able to serve all these parts of the hydrogen landscape. So from the beginning, the creation or the production, all the way up to the consumers, we have something to offer. In this case, my department is mainly on the right-hand side of the screen. We are mainly involved in automotive industries. But, well, as we all know each other within KIWA, especially when it comes to development projects like hydrogen, we are very closely communicating with each other. So questions which are asked to me, I can postpone, of course, I can communicate them internally to other companies within KIWA who are able to serve your question. That's what we call the one-stop shop principle. Next slide, please. Several markets, what I already mentioned before, it's very diverse. You can see from maritime to offshore to medical health, it's all fitted into one company. It's very diverse to work for as well. For example, a pilot which flies KLM, when you fly from Amsterdam to Seoul, the man behind the wheel has also an accreditation made by KIWA. If you go back from Seoul to Amsterdam, you jump into a taxi. The taxi driver also is having a KIWA certificate. So it's very wide, very various markets we are able to serve. Next slide, please. What I mentioned also as before, the hydrogen supply chain just goes throughout the entire KIWA organization. What I would like to mention now is, well, because I'm representing the lab alternative fuels and pressure products, meaning that it's a lab situated in Arnhem, in Arnhem and Apeldoorn, where we are mainly testing and certification on hydrogen-related components. This could be a material, this could be a component, this could be a tank. We are in a situation that we are accredited and assigned by the Dutch and the German roadworthy authority, meaning that we can also perform type approvals. So if you have a component and you want to put it in any market, it could be European, could be US, could be even Asian markets, KIWA is able to do the testing and do the certification. Our test data is accredited. That means we are ISO 17025 accredited. So all the data we are generating can be used for certification purposes as well. So it does not mean that we have to do or have to fulfill the entire project. We can take a part from a project, take the test data to a notified body, and then well, validate it, and it's usable for your type approval. Next slide, please. We have the upcoming year, 2021, would be a very important year for KIWA in Apeldoorn. We are investing in our hydrogen testing lab. At the moment, we are already having quite an extensive capacity, but as we see that the market is growing, has been decided we are investing, let's say, 2 million euros in our lab for especially for hydrogen testing on tanks, but also on components. A slide overview has been given here. So it's up to 125 temperature in the plus, minus 40 in the minus, which are generally the ranges for automotive industry. We see at the moment that the tanks even are getting up to 600 to 700 liters, 700 bar on hydrogen gaseous contents. And we try to well, look away in the future a little and see if that would be also in our capacity. And up to now it does. Thank you. Next slide. I don't know if this works. No, it doesn't work. It was a short animation we made, but well, we went quite fast past it. This would be an example of the equipment we're going to install. It's a box-shaped 40-feet container where we have several from them. This would be the driver, so to speak, with the intensifier, the hydraulic module, and the pre-fill module. With this, we are then able to test and do the testing on site. Next one, please. Here I try to address that because we're mainly involved in our department in automotive. Even this is a hydrogen-related presentation. I would like to mention that we have other gaseous fuels we are able to serve. So in the first beginning, let's say the last decade, we changed a lot to hydrogen, but LNG, LPG, and CNG, and also biogases are common in our company. On the left-hand side, you see a list of quite typical standards we are able to do the certification for. As well, and it says here in the bottom line, but it should be a little bit up. We are also able to do ADR, PED, and TPED approvals, meaning that we are able to do the full certification for the Transport Pressure Equipment Directive. Next one, please. Some other tests. This is just an overview. I will not mention any of them, but it just gives an idea how versatile our lab is. So all our test equipment is modular, meaning that we can create or build a test setup which is not according to a given standard, which gives us quite a flexible layout of our lab. So strange test, I have to call them strange tests because some happens all the time that then we come back in the lab and there are some engineers that are really making something nice of it. For example, we are also at the moment certifying face masks for, well, we have all noticed that we have the COVID virus running around. So we are also certifying that in our lab. So that's just an example how versatile KIWA can be. Next one, please. Well, this is one of our principles, the one-stop shop, meaning that there's so much services possible at KIWA that we have mentioned it and we call it a one-stop shop, not only in a hydrogen-related business, but also in several other typical questions you can have. Please don't hesitate to contact us. I think after this session we have a Q&A. So if you have any questions, please let me know. This was it for me. Thanks for your time. Thanks for your attendance, and well, hope to hear from you soon. Thank you.
Thank you, Don. The next speaker from the Netherlands is Mr. Marcel Katterberg from Bronkhorst.
Yeah, good morning. Good morning. Welcome, everybody. I would like to tell about Bronkhorst, what we do and what we have to offer for hydrogen. But first, let me introduce myself. My name is Marcel Katterberg. My background is electrical engineering. I worked for many years in R&D and product development. And besides some other things, I now do business development for hydrogen. At Bronkhorst, we believe that it's very promising, hydrogen, and we want to contribute to the energy transition. And we believe we can do so with our products. Next slide, please. So a quick overview of this presentation. First, a quick introduction of Bronkhorst. And then a slide of hydrogen versus hydrogen power versus flow. I have some example applications in hydrogen and flow measurement. And discussion will be later. Okay, next slide. Okay, so we develop, manufacture and sell mass flow meters and controllers for gases and liquids. And these instruments are used in various industries and applications. We do a lot with hydrogen and also for chemical application, semiconductor industry, where hydrogen is used as the carrier gas. And beside those applications, we can bring a solution for green hydrogen. And we do that already for many applications. But we expect to find many more in Korea and Japan. And that's why I'm here today. A quick overview of Bronkhorst. So we do mass flow meters and controllers for gases and liquids. You see some of the instruments in the picture on the right. Mostly we focus on the lower flow range. Bronkhorst is founded in '81, privately owned. We have about 600 employees worldwide. We are market leader in Europe. And we have 20% employees active in R&D and engineering. Okay, next slide. Bronkhorst has many subsidiaries and distributors all over the world, also in Korea and Japan. And with these offices, we can offer local sales, support and service. And this is also handy for machine builders and system integrators that build in our products, as we can support you in the country where the application is in operation. Next slide. Okay, so hydrogen is not a source of energy, it needs to be produced. And the production of hydrogen uses a lot of power. And for the production of green hydrogen, green electricity is converted into hydrogen with electrolyzers. And the produced hydrogen can be then stored for later use. For generating 1 kilogram per hour of hydrogen, you typically need about 50 kilowatts of electric power. And so that's where our instruments can be of use. We can measure the flow that comes from the electrolyzer. And if you want to use the stored hydrogen to be converted back into electricity, we can also measure that amount of flow. So the 1 kilogram per hour of hydrogen, if you want to convert it back into electricity, you will end up with approximately 17 kilowatts. And so from electricity to hydrogen, back to electricity again, you see that you will have an overall efficiency of about 30%. That's typical going on today, although systems keep improving. In this picture, I did not take into account any additional loss in compression of the hydrogen. Okay, next slide. Okay, so where can our instruments be of use? Any type or brand of fuel cell has a specific behavior or needs specific conditions for optimal operation. And the hydrogen that's being fed to the fuel cell typically has to be moisturized because dry hydrogen gas causes the fuel cell to operate poorly. And Bronkhorst can offer gas flow meters and controllers to measure or control the amount of gases to the fuel cell. Furthermore, we have liquid flow controllers and evaporator systems that can generate moisturized hydrogen for optimal working conditions of the fuel cell. And furthermore, we have pressure meters and controllers that can control the pressure in the fuel cell. Our products are often used in R&D and testing and quality control. And you can easily change the parameters to investigate the fuel cell under different settings, to find the optimal configuration, or to find out when your fuel cell starts to perform poorly. On top, you see the reaction equation from water to hydrogen and oxygen, or the other way around. And in these chemical reaction equations, you see the ratio between the molecules is very convenient for thermal mass flow instruments, as you can use the same size of the instrument to measure both the hydrogen and the oxygen. So that's an advantage of the usage of thermal instruments. Okay, next slide. So in general, for any gas flow application, we have instruments, different types, different embodiments, different flow ranges, pressure ranges, and measure principles. And on the right is our smallest instruments. Okay, next slide. The same as for liquid instruments. Besides the thermal measurement principle, we have Coriolis, ultrasonic, magnetic, and vortex flow meters and controllers. Okay, next slide. Okay, this is about our evaporator systems and modules that can be used to deliver constant vapor to your fuel cell. Our evaporators can go up to 1.2 kilograms per hour of water vapor, water equivalent. We have third-party supplies that can go up to 10 kilograms per hour, and you can mix various gases before moisturizing, or you can use dilution gas after the evaporator. So you can create any gas mixture with any vapor concentration for fuel cell operating and testing, or other applications where vapors can be used. Okay, next slide. This is another example application. It's a fuel cell poisoning. Mostly hydrogen today is still generated from steam reforming. Steam reforming causes a lot of carbohydrates in the hydrogen, and also carbon monoxide can be present in the gray hydrogen. And carbon monoxide, we know that it can damage a fuel cell. But Bronkhorst can offer instruments to test this. So you apply a hydrogen to your fuel cell and you mix a little bit of carbon monoxide into the hydrogen to see how your fuel cell reacts to that. There's also an ISO directive, ISO 14687, that states that for using fuel cells, the hydrogen needs a purity of 99.97%, and only 0.2 ppm of carbon monoxide is allowed. Now, if you buy any typical laboratory grade gas, then only the hydrogen 6.0 meets the carbon monoxide level. Although it's very pure, that's the first hydrogen quality that is good enough for fuel cells. You can also test again the fuel cell under different pressures. So therefore, in this picture on the right side, you see a Bronkhorst pressure controller. Next slide, please. And with our pressure controllers, you can control the upstream or downstream pressure and depend on the type of pressure controller. So it's upstream or downstream pressure control. That's what we can do for you. Next slide, please. Here I have another example. It's hydrogen production. We use usually our larger size instruments for this. The inflow industrial style instruments, they are ATEX zone 2 capable. They come in various pressure ranges from 40 to 700 bar maximum. And we have different flow ranges in two different types of instrument. So this, on the lower end, we go up to 100 cubic meters per hour, normal cubic meters per hour. That's for the typical electrolyzer size of a 0.5 megawatt. If you have bigger systems or multiple systems together, then we have larger instruments for that as well. In the picture below, you see our instrument directly operating membrane valve. Advantage of Bronkhorst products is that the circuit board has onboard PID controller that can be used to directly operate valves and pumps. And in that manner, you can not only measure, but also control flow. Next slide, please. That's also for our liquid instruments. Here are some examples of our liquid flow meters in combination with different actuators, with electromagnetic control valves, pumps, or membrane valves that can be hooked up to the meter directly so that you can control mass flow, and you do not need a combination of a PLC and a control valve. The control is being done by our instrument, which makes it very convenient. Okay, next slide, please. This is the last example that I have for you. It's odorant delivery. We know that the odorant for hydrogen is still an issue. Odorization needs to be done in order to smell any gas leaks. But the odorant used in natural gas is cannot be used for fuel cells because the sulfur contents of today's used odorants can damage your fuel cell. So people are still looking for the right type of odorant, but we already use this for natural gas. In the lowest picture, you see our liquid flow control in combination with the pump. It's an ATEX zone 1 solution, and it's used for applying odorant to natural gas in a master-slave setup. So if you know the flow rate in your main gas pipe, we can deliver a percentage of odorant to the natural gas. And so independent of the flow rate in your main gas pipe, you will have the same percentage concentration of odorant in your system. Okay, last slide. Okay, that's my presentation. Thank you all. Questions can be asked later, or you can directly contact our local sales office in Korea. Thanks.
Okay. Thank you, Dan. Thank you, Marcel. So now we move to the Korean invited speaker, Dr. Yang from KIER, the Director of Future Energy Research at Korea Institute of Energy Research.
네, 안녕하세요. 제가 오늘 요거 가지고 하시면 될 것 같습니다. 그러면 이거로 넘기면 되겠네. 네.
Sorry for the inconvenience. We just found some technical problem. We'll resume soon.
네. 한국에너지기술연구원은 수소연료전지를 오랫동안 연구를 했고요. 한 40년 이상, 내년이면 연료전지 연구를 시작한 지 40년이 됩니다.
So KIER is a research institute in Korea. It was a pioneer in hydrogen research. So next year will be their 40th year for KIER to work on hydrogen.
네, 저는 수소 연료전지를 20년 넘게 연구를 했고요. 그리고 저번에는 정부의 수소 연료전지 프로그램 디렉터로 R&D 기획을 담당했었습니다.
So Dr. Yang himself has been working on fuel cell for 20 years, and he worked in the government sector for R&D planning.
뭐가 필요할까요? HDMI. 네, 오늘 발표에서는 한국의 수소연료전지에 대해서 전반적인 소개를 하겠습니다.
So from his speech today, he will present general information about Korean hydrogen. I think the slide is almost ready to share.
네, 안 봐도 됩니다. 네, 그냥 하죠.
So meanwhile, they're preparing for 20 research in hydrogen fuel cell. What's your spectrum from fuel cell? Did you 그러면 한국에서 연료전지 어떤 연료전지 쪽을 많이 하셨다고 보면 될까요?
한국에서는 수송용 연료전지로 폴리머 PMFC하고 MCFC, PAFC를 많이 연구를 했고요. 지금 현재는 SOFC 연구가 많이 진행이 되고 있습니다.
So he has been focusing. I asked what were the fuel cell focus on his research, and he said he used to focus more on the mobility side of fuel cell, like PMFC, and then MCFC and PAFC. But now he focused more on SOFC.
네, 한국에서 지금 현재 설치대에서 운전되고 있는 다양한 연료전지들을 보여드릴 거고요. 그 외국 제품과 비교를 한번 해보겠습니다.
So he will present about these fuel cell installed in Korea, what kind of installations are done, and he will compare with other foreign countries.
네,
안 돼요? 그럼 그냥 그걸로
네?
하시죠. 네. 네, 그건 다음으로 가시죠.
네. 네, 넘어가겠습니다. 네, 오늘 발표할 내용이고요. 한국의 수소연료전지 수소경제 로드맵, 그리고 현재의 수소연료전지 기술과 시간이 좀 남으면 우리 한국에너지기술연구소의 현황에 대해서 소개를 하겠습니다.
The presentation consists of hydrogen energy roadmap, which was announced in 2019, and secondly, the current status and the future plan. Finally, on KIER's activity, if time allows.
네, 작년 2019년에 정부에서는 수소경제 로드맵을 발표를 했습니다. 이게 현재 문제가 되는 기후 변화 대응을 하는 게 이제 가장 큰 문제 이슈고요. 그리고 이제 수소를 이제 미래의 에너지원으로 적용하게 해서 정부의 이제 우리나라의 성장 동력 산업으로 육성하겠다는 목표를 가지고 대통령께서 발표를 했습니다.
In order to boost the economy along the growing the dependency on imported fuels, and also the climate change, the Korean government has set an ambitious hydrogen energy roadmap in addition to their renewable energy plan.
네. 일단은 수소경제의 비전은요, 수소경제 사회를 이끌 수 있는 세계 인류 국가가 되겠다는 게 이제 큰 비전이라고 말씀드릴 수 있겠습니다.
The vision of Korean strategy through this hydrogen roadmap is to become the leading group, in the hydrogen development.
네, 이 수소 경제는 크게 이제 3단계로 나눠져 있는데요. 1단계에서는 일단 수소 경제 사회를 진입하기 위한 준비 단계라고 볼 수 있겠습니다. 수소에 대한 이제 인프라스트럭처를 갖추고 법제도 정비하는 것을 포함을 하고 있습니다.
So this strategy divided into three phases. The first phase is entry phase to establish the hydrogen infrastructure and prepare law system and regulations.
세컨드 페이지에서는 이제 수소의 이용을 높이고 이제 수소 생산 설비를 이제 대규모 스케일업 하는 게 이제 주 타깃이 되겠습니다.
The second phase is to expand the application of the hydrogen and construct large-scale hydrogen infrastructures.
이제 3단계에서는 이제 본격적인 수소 경제 진입을 위한 준비 단계가 되겠는데 그러기 위해서는 이제 그린 수소를 생산하는 수전의 기술과 그리고 CO2 프리 수소를 만드는 시스템 그리고 이제 미래에는 수소가 모자랄 거라고 생각이 돼가지고 수소를 해외에서 도입하는 것까지 고려를 하고 있습니다.
The third phase is to focus on the green hydrogen production by electrolysis and also the CO2-free hydrogen production, and also import technology for hydrogen.
네, 이 슬라이드에서는 그 각각의 이제 정량적인 목표들이 나오고 있습니다. 연료전지 자동차 수소 충전소 그리고 연료전지 발전 그리고 수소 공급량에 대한 연차별 목표를 잡고 있습니다.
So this slide shows the quantitative targets for hydrogen roadmap in Korea.
네, 대표적으로 연료전지 fuel-cell vehicle 같은 경우에는 2040년까지 약 600만 대를 생산하는 것을 목표를 하고요. 누적치입니다.
So this plan has to focus on increasing total fuel cell vehicle to around 6 million units cumulatively.
네, 수소 충전소는 약 1,200기.
To 1,200 refueling station.
네, fuel-cell 파워 플랜트 같은 경우에는 15기가와트를 만들고요. 8기가와트를 국내에 설치하기로 계획을 잡고 있습니다.
So for the power plant users is targeted for 15 gigawatt production and 8 gigawatt will be installed in Korea.
아시겠지만 8기가와트는 거의 원자력 발전소 8기에 정도에 해당되는 발전량이 되겠습니다.
So 8 gigawatt is comparable to the 8 nuclear reactors.
수소 경제에 관심이 많은 나라들 다 같은 문제를 가지고 있는데 수소 가격을 어떻게 낮추느냐가 이제 가장 큰 관건인데요.
So all these countries who are interested in hydrogen has similar problem of the price of hydrogen.
Yes, cost reduction이 가장 큰 이슈죠.
So cost reduction is the most important issue.
Yes, 모든 게 2040년 정도에 킬로그램당 약 3,000원 정도를 약 3불 미만으로 생산하는 것을 목표로 잡고 있습니다.
So the target for the production price is under $3 per kilogram.
킬로그램이요.
Per kilogram by 2040.
2040년 정도 되면은 국내 수소 양 가지고 모자랄 거라고 내가 생각이 돼서 CO2 프리 수소를 외국에서 도입하는 것까지 계획에 잡고 있습니다.
By 2040, we expect that there will be shortage in the hydrogen production in Korea. So we are also planning to import hydrogen.
현재는 대부분의 수소는 그레이 수소입니다.
So current hydrogen production are mostly coming from the gray hydrogen.
천연가스로부터 생산되는
From natural gas.
Yes. 네, 이 표는 전 세계의 수소 연료전지 플러스 충전소 그리고 수전의 시스템에 이제 보급되어 있는 상태를 비교를 한 표입니다.
This diagram shows the overall status comparison between the countries.
네, 뭐 IPH에서 그리고 자료를 정리를 한 IPH에서 얻는 자료를 정리했고요. From IPH.
So he used the data from IPHE.
네, 네덜란드 같은 경우에는 수소차가 그래도 유럽에서 많이 보급이 되어 있는 상태인 것 같습니다.
So Netherlands, comparing to other European countries, has a lot of the fuel cell vehicles already on road.
한국의 경우에는 현대에서 연료전지 자동차를 만들고 있기 때문에 최근 들어가지고 약 7,682대가 국내에 보급이 되었고요.
So because Korea has the Hyundai Motors who produces hydrogen vehicles, 7,682 cars are already on road in Korea.
네, 그리고 2,000대는 수출을 했습니다. 주로 유럽 쪽이죠.
And 2,000 cars are already exported to mostly Europe.
그리고 이제 또 특이할 만한 사항은 그 large stationary fuel cell이 많이 보급이 되어 있습니다.
You can notice that there also large stationary fuel cells are largely implemented in Korea as well.
네, 보급량으로 따져 놓고 보면은 금년 말이면 세계에서 제일 많을 거라고 생각됩니다.
So by this year, the Korea will be the country with the most capacity for the hydrogen stationary applications.
이와 더불어서 그 연료전지 잠수함과 드론도 상용화되어 있는 상태입니다.
In Korea, also submarine and drones are commercialized for hydrogen use.
네, 수소 생산 계획을 살펴보겠습니다. 수소 생산 계획은 그 2040년까지 약 500만 톤의 수소를 연간 생산하는 것을 목표로 잡고 있는데요.
So for Korean hydrogen production roadmap, by 5 million ton per year will be produced by 2040.
Yes. 네, 현재는 주로 이제 그 석유화학 공장에 나와서는 바이프로덕트 하이드로젠을 많이 사용을 하고 있고요. 일부는 천연가스에서 리포밍을 통해 가지고 수소를 만들고 있습니다.
So most of the hydrogen currently is supplied from the byproduct hydrogen, but some are supplied from the reforming process.
네, 나중에는 주로 이제 그린 수소인 수전해 그린 수소 수전해로부터 그린 수소를 만들 계획입니다.
So in future, the plan is to produce green hydrogen from electrolysis.
Yes. 그린 수소에서 가장 큰 문제는 전기값인데요. 이 전기값 싼 지역에서 수소를 만들어야 하기 때문에 해외에 수소 공급망 구축에 대해서도 관심을 가지고 있습니다.
For green hydrogen production, the electricity cost is the most critical part. So Korea is considering to import hydrogen from where the electricity price is lower.
네, 이거는 그 그린 수소를 생산하는 알칼라인 일렉트롤라이저의 비교 그림인데요.
So this diagram shows the current status of the alkaline electrolysis.
네, 한국의 수소 산업에서 특히 수소 생산 분야가 좀 취약한 상태입니다.
The Korean industry, hydrogen industry, production sectors are weaker.
예, 그래서 국제 공동 협력을 많이 추진을 하고 있는 상황이고요.
That's why the Korea is also active in international collaboration on this.
예, 유럽의 넬이라든지 그 맥파이라든지 그런 회사에 비교해 봤을 때는 그 일렉트롤라이저의 캐패시티하고 효율이 좀 많이 떨어지는 걸 볼 수 있습니다.
So Korean products are still lower in the capacity and efficiency comparing to NEL or other top class companies.
네, 그래서 R&D가 수소 생산 쪽에 지금 현재 집중이 되고 있는 상황입니다.
So Korean R&D fundings are mostly on this production technology.
이거는 이제 천연가스 리포머 기술 쪽의 비교인데요.
This is a diagram for comparing the natural gas reformers.
예, 저 리포머 플랜트가 수소 생산 플랜트 같은 경우에는 주로 이제 에어 리퀴드라든지 에어 프로덕트 린데가 이제 주로 시장을 꽉 잡고 있습니다.
So large scale hydrogen reformers are mostly dominated by these large companies like Air Liquide, Air Product, and Linde.
근데 이제 그 작은 용량의 이제 온사이트형 수소 생산기 같은 경우는 현재 경쟁 구도가 이루어져 있는 상황이고요.
But the smaller reformer market is competitive. The competition is becoming intense.
오사카 가스가 그 유명한 제품을 판매하고 있는 상황이고요.
The Osaka Gas has the most well-known product.
한국에서는 에너지기술연구원이 200kg급, 500kg per day급 계질기를 개발을 해서 지금 장기운전 평가에 들어가 있는 상태입니다.
And in Korea, KIER has developed the 200 kilogram per day and 500 kilogram per day gas reformer, and they are under operational testing.
네, 지금 이게 그 각각의 기술별로 그 부품들을 이제 나타내는 건데요. 현재 그 200kg per day급 같은 경우는 1000시간 이상 운전을 한 상태고요.
So these images shows the products, the gas reformer products from KIER, and for 200 kilogram per day reformer, it was tested for more than 1,000 hours now.
네, 장점은 가격을 낮췄고 효율을 높인 것 그리고 컴팩트하게 설계한 게 이제 장점이라고 말씀드릴 수 있겠습니다.
So the strengths of this product is that it has a lower price but higher efficiency, also the compact design.
네, 이제 스케일업 하는 지금 시도도 지금 진행 중입니다.
And they are trying to scale up the capacity.
네, 이거 리포머의 이제 스펙인데요. 전체적으로 리포머와 PSA까지 해가지고 100% 이제 국내 생산이 가능하게 개발을 하였습니다.
So this is a diagram to show the specification of this reformer from KIER, and as you can see, the reformer and PSA were all now almost 100% localized.
리포메이트 하이드로젠 같은 경우는 ISO 규격에 현재 맞춰져 있는 상황입니다.
And reformer is also compliant with ISO standard.
네, 그다음에 이제 수소 충전소의 보급 계획인데요. 현재 2040년까지 1200기까지 늘리게 되겠는데요.
So this is a plan for government's plan to expand the refueling station infrastructure. By 2040, 1,200 stations will be installed.
네, 우선적으로 서울과 부산, 대전 등 대도시 위주로 설치를 하고.
So the prime target for now is the bigger cities like Seoul and Ulsan, Busan.
네, 그리고 고속도로에 이제 충전소를 우선적으로 설치할 계획입니다.
And they will also install while in the highway as well.
네, 특히 하이드로젠 모빌리티 쪽에 수소 선박에 대해서도 지금 개발이 추진 중에 있습니다.
And the hydrogen ships are also under development in Korea.
예, 적어도 메가와트급의 연료연지 시스템 개발과 실증이 필요한 상황이고요. 현재 추진 중에 있습니다.
So the megawatt level of hydrogen fuel cell is required for this, and they are under research now.
네, 발전 쪽에서는 이제 아까도 말씀드렸지만 large scale stationary power plant가 지금 보급이 많이 되고 있는데요. 그와 더불어서 홈 레지던셜하고 빌딩용 컴바인드 히 파워 플랜트도 같이 병행돼서 보급이 확산되고 있는 상황입니다.
In Korea, as you saw in the last diagram, large scale stationary fuel cells are already installed quite broadly, and also the residential and building CHP applications are now under dissemination.
정부의 보조금 지원 정책이 확실한 시장을 만들고 있습니다.
Korean subsidy programs are supporting this market.
그 large stationary power fuel cell 시스템 같은 시스템을 비교를 해놨는데요.
So this is a diagram to compare the large stationary fuel cells.
네, 주로 이제 한국에서는 PMFC가 아니라 PAFC, 두산의 PAFC와 포스코 에너지의 MCFC가 보급이 많이 돼 있는 상황입니다.
So in Korea, PFC and MCFC is mostly installed.
최근에 블룸 에너지 제품이 한국에 들어오고 있는 상황입니다.
And recently, the Bloom Energy SOFC is now installed in Korea as well.
예, 효율에 약간 차이가 있는데 시장에 따라 가지고 그 전기 발전이라든지 열 쪽에 맞춰 가지고 시장에 맞게 제품이 선택되고 있는 것 같습니다.
And there is some difference in efficiency, but by the market demand, they will choose either heat or electricity more, and that is the key element for choosing what kind of technology they choose.
스몰 스테이셔너리 시스템 같은 경우는 다양한 제품들이 지금 많이 나오고 있습니다. 일본, 한국, 유럽 쪽에서 제품이 출시되고 있고요. 시장이 점점 커지고 있는 상황입니다.
And this residential and building fuel cell market is growing with the different types of fuel cell developed by the Europe and Korean developers.
한국 같은 경우는 다양한 용량의 모델이 나오고 있는 게 좀 특징입니다.
In Korean market is you can see the market is divided into various size of capacity models.
네, 수소 하이드로젠 모빌리티 쪽에서는 잠수함 지금 현재 데몬스트레이션이 지게차 그리고 굴삭기, 배의 이제 실증이 지금 이루어지고 있습니다.
In field of the hydrogen mobility, already fuel cell submarine is deployed, but the forklift and excavator are in the process of demonstration and other parts in R&D.
네, 배와 네. 그리고 뭐 개인적으로는 지금 수소 그린 가스 에미션이 많은 트럭이라든지 버스, 택시의 보급이 많이 일어나야 되는데 현대에서 지금 세계 최초로 수소 전기 트럭을 팔고 수출하고 있는데요. 이게 좀 더 시장이 확대돼야 될 것이라고 생각됩니다.
Personally, he thinks that hydrogen has to be used more on the mobility side to compensate the greenhouse gas emission. And Hyundai Motor has recently introduced the fuel cell truck and now is sold in Europe.
네, 지금부터는 R&D 스테이트 플랜인데요. 간단하게 그 수소 생산과 관련돼 가서는 수전해와 그 리포머의 스케일업 연구가 좀 더 진행이 되고 있습니다. 진행이 될 예정입니다.
Yeah, from this slide, he'll discuss about the R&D status, the electrolyzer, and the hydrogen production R&D will be performed.
연료전지의 경우는 이제 그 부품 소재에 좀 더 기술 고도화가 필요로 하고 있고요.
And fuel cell, the components and the material has to be more developed.
그리고 이제 앞으로는 좀 대용량의 SOFC 시스템 개발에 주력을 할 예정입니다.
And high capacity SOFC is the target, one of the focus for the KIER.
네, 모빌리티 쪽은 뭐 아까도 말씀드린 것처럼 이제 다양한 시도가 되고 있고 최근 들어가지고 파워 투 가스하고 하이드로젠 커뮤니티 쪽에 그 R&D가 확대가 되고 있습니다.
In mobility, there are a lot of the applications now being tested, and power to gas and hydrogen community are the new sectors that the research will be focused.
네, 이게 한국에너지기술연구원의 소개인데요. 특별하게 저희 연구소 같은 경우에는 수소와 연료전지 개발에 집중을 하고 있는데요. 간단 대표적인 성과를 하나 보여드리겠습니다.
And from this slide, he will show about the achievements from KIER, and the KIER is focused on hydrogen and the fuel cell research.
특별히 이제 수소 연료전지 쪽에선 가격 저감과 내구성 향상이 중요한데요. 그 관련돼 가지고 가격 저감을 위해서 플라티늄 로딩을 4분의 1 이상 줄였고요. 그리고 성능도 2배 이상 정도 올라가 있는 상태입니다. 그리고 저가의 하이드로카본 베이스 멤브레인도 개발을 한 상태고요.
So for fuel cell, the lowering price and the durability increase is the focus. So the KIER has successfully done the research to reduce the loading of the platinum in the quarter, and also increase the performance and also the hydrocarbon membrane.
네, 에기어는 우리 한국에서 제일 큰 연료전지 성능평가 센터를 구축을 하고 있고요. 지금 많은 기업들이 활용을 하고 있는 상태입니다.
And KIER also have the infrastructure to test the largest infrastructure in Korea to test the fuel cell in Korea, and has been operating for.
뭐 이쪽 관련돼서도 유럽과의 협력이 가능할 거라고 생각합니다.
And he think that this is also the area for possible collaboration with Europe.
예, 그린 암모니아 같은 경우는 미래 수소 저장 수단으로 좋을 거라고 생각되는데요. 이와 관련된 연구도 진행 중에 있습니다.
And green ammonia is considered as a attractive material to carry hydrogen, and KIER is also working on this.
네, 감사합니다.
Thank you. Okay. Thank you, Dr. Yang. And now we will have some time for discussion, I think. I think because of the time constraint, we'll just have 5 minutes about one or two questions. I'll get the questions from the audience. Okay. So there's one question to you, Dr. Yang. Somebody asked, I think from the YouTube or Zoom, for 8 years, KIER has worked on the project to produce hydrogen from algae.
Hydrogen from yes.
And is this project still running? Is KIER or Korea working on developing other innovative way to produce hydrogen?
그 관련돼가지고 LG를 이용해가지고 연구 되는 거는 아직도 같이 병행해서 진행 중에 있고요. 기초 원천 연구로.
So the basic research is still ongoing on the algae oriented hydrogen.
네, 그와 더불어서 바이오 수소를 생산하는 세균을 박테리아를 이용해가지고 바이오 수소를 생산하는 기술도 지금 진행이 되고 있습니다.
There's also research on working on bacteria turning the biomass to hydrogen.
Yes.
이 연구들도 그러면 본부장님 랩에서 진행이?
아니요, 그건 아닙니다. 지금 그쪽은 해수부 해양연구소 쪽에서 진행이 되고 있고요. 심해 박테리아를 가지고 하는 바이오 수소를 만드는 연구가 따로 진행이 되고 있고, LG를 이용해서 하는 거는 현재 좀 주춤하는 상태입니다.
So this new technology is developing under the Ministry of Ocean and Fishery funding to use the deep water bacteria to produce the hydrogen. 그러면은 예전에 제가 알기로는 촉매를 이용한 수소 불분해도 있었는데
그거는 지금 촉매를 이용하는 그러니까 수전해 기술이 되겠는데요. 수전해 기술은 지금 정부에서 집중 육성하고 있는 기술로서, 그리고 원천 기술에서부터 시스템까지 지금 전방위에 대해서 지원을 하고 있습니다.
So for electrolyzer research, this is one of the government's key funding area for R&D. And
네, 그래서 제주도 쪽에 재생에너지가 많은데 파워 투 가스를 지금 실증을 하고 있습니다.
So in Jeju Island, which is the island located in the far south of Korea, where we have abundant renewable electricity, there the KIER is also testing the green hydrogen production from there. I think time is almost up, so the last question I can see maybe to NRR to FOUD. There are not many regulations now for hydrogen yet, but the developments are going faster than the regulations. So, can you work without the regulation, or how are these regulations are really made? How is the regulation is?
It's a very good question. Yeah, you will have this case a lot of time where technologies advances much faster than regulations are set, but mostly in projects between institutes and governing bodies, they try to also evolve and look at this regulation closer and try to develop them faster if possible. And what you can always do is try to, when looking at hydrogen, keep certain aspects into mind when developing your own product. Like I mentioned, safety analysis becomes then more and more important. In aerospace, the standards regarding safety are already quite high. So if you take those regulations and derive them to the situation of hydrogen, let's say components of complete systems, you can still develop. and sometimes in close, let's say, collaboration with authorities like EASA, they're always willing to talk and think also with industry and institutes to see on how to accommodate them in let's say this kind of new technology.
네,
I hope that answers the question.
한국에서도 세이프티 레귤레이션이 가장 중요한데요. 사실은 없어서도 안 되는 문제인데 이것 때문에 기술 개발을 방해를 할 수 있거든요. 그래서 한국 정부에서는 규제 프리존을 만들어 가지고 지금 그 수소 연료전지에 대한 그 연구 개발을 좀 가속화시키고 있습니다. 보급.
So in Korea, also the regulation for safety is a critical issue for R&D because this sometimes become a hurdle for R&D. So Korean government now have this regulatory free zone in certain places so that the hydrogen research can be more freely do their testing and research.
Yes, I think it's similar here in the Netherlands as well, where if we look at aerospace and testing, NLR has its own airspace, so we can do experimental testing, and that will also help, I think, regulatory bodies and authorities to come up with standards and regulations that accommodate this kind of technology as well. So I think we have a similar situation as in Korea.
Do we have time for other question? One more? 지금 저한테는 안 하는데.
제가 질문하면 될 것 같습니다.
예.
네. Hi, this is Song from Hyundai Motor Company. I'm working with the hydrogen energy business development team. I have one question to TNO, Mr. Leonard van der Berg. I don't know if I have pronounced your name right, but as I know that TNO has been working on the development of the methane pyrolysis technology for a long time, and I was wondering about the status of your technology development of that technology, and I would like to hear from you about the plan for the future.
Heiko? Yeah, Heiko, did you get the question?
Yeah, I had the question, but I thought my colleague was answering him, but apparently not. Yeah, to be very honest, I have to look into that. I know they have been working many years on that technology, but I don't know on top of my head the latest status. But if you don't mind, I'll come back on that one.
Okay, I think Mr. Song, if you can give us the contact information of yours, then we'll deliver that to TNO so that you can talk to the right person.
Okay, I'll give it to the minister later.
Okay, thank you.
Yep.
I think because of time delay, we cannot have have all the questions be answered. But certainly, I'll try to get this to connected to the right person so that we will do some matchmaking. And thank you all for the presenters and viewers today. We will have another webinar session tomorrow at 3:30 p.m. Korean time and 8:30 a.m. Dutch time, and with also interesting speakers on hydrogen infrastructure in urban application. We'll also talk about this regulatory-free zone, which is a new topic also in Korea. So it will be very interesting. 내일도 이제 같은 시간에 유튜브 실시간 방송으로 찾아뵙겠습니다. 많은 시청을 부탁드리겠습니다. Thank you for watching and see you all tomorrow. Bye.
감사합니다.